Okay, this is the second review question on the worksheet. So this question is what I consider one of the easiest questions on the test. The time required to finish this problem should be less than, I would say, 30 seconds, definitely less than 1 minute. What I'm seeing from this problem, though, is that some students are struggling to get through this question very mightily. And based on my analysis, I would go through the following, is that many of you are not seeing the possibilities, or many of you just went ahead with whatever strategies that you could come up with, but you couldn't see the outcome, but you still execute your action nonetheless. And that's why things got very chaotic at the end. So I've seen a lot of people doing the following two things. One group of students would do this. They would just write down x is equal to -1 and then 2. Okay, that's it. That's the answer. The other group of students would actually do something like this. The other group of students would actually try their very best to expand this whole thing out. I'm not sure what they're thinking. I mean, that's, well, in terms of right and wrong, it's not wrong. It's just that it gets you to nowhere. That's a problem. Like, can you make a huge, gigantic expression? I mean, you could definitely do that, but you really won't get anywhere. Okay, so they did so much work and they got nothing out of it. And the reason is because they tried something without knowing where they're heading to. That's why it's really problematic. So this is where you have to understand what you could do. So that's one possibility out of a few options. That's not the only possibility. The other possibility is that whenever you see a polynomial like this one right here, you can actually make a very simple graph. Okay, and as I said in class, this is actually what you will need in the next level in calculus. Okay, and I'm not trying to scare you, I'm just telling you the truth. So I really hope that you will take this advice. So if you so the expansion part, it's not going to get you anywhere, but the graphing part could get you to the destination in no time. So you can practically tell the roots. The roots will be -1 and 2, while the 2 will have the multiplicity of 3. So that means you have to make sure that you can graph it properly. The degree of this polynomial, it's 4, not 3. The way you tell the degree properly is that you have to imagine, if you are going to multiply it out, you have x cubed, right? You're going to multiply it out, you will end up with an x cubed. And then you will have an x to multiply as well. So you will end up with the x to the 4th power as the largest power in the polynomial. So that's how we can tell the degree it's 4. And the sign of this polynomial, it's positive, since everything in the parentheses, they are x plus or minus something, and there's no negative number in front of the factors. So we just say, hey, let's go ahead and just positive sign. And because it's a 4th degree, it is a positive sign for the leading coefficient. It must start high and end high. Now, if you still have some trouble understanding why it starts high and high, and you are relying on your memory to get this, then I would say, let me give you a very simple advice. If you have x to the 4th power as the leading term of the polynomial, And then go ahead and imagine x equals to -10. Okay, just go ahead and imagine that. What is -10? The whole thing, okay? Multiplying by itself 4 times. Multiplying by itself 4 times. Would it be a positive number or a negative number? Okay. So negative times negative, it's positive, and then times negative, and times negative. Well, then you will end up with a positive number, right? So if you cannot visualize this, I'm going to show you here. Okay, so again, imagine x to the 4th, x being -10. So you have all these negative tens multiplying by each other, by itself 4 times. So the 2 negative will multiply to become positive. The other 2 negative signs will multiply to become positive. So that's why you end up with a positive. So that's the reason why if you have a very negative number, it would end up with a pretty positive value. So that's why it starts high right here. And that's also the reason why it ends high, because if you have a positive number multiplying by itself 4 times, you will end up with a positive number. Okay, so I will hope that you can try your very best to understand why that's the case. Okay, let me take this away. And then another very important piece of information, it's your y-intercept. And the y-intercept, it's when the x is equal to 0, right? So if x is becoming 0, so you have 1 times -2 cube. -2 cube, it's -8 times 1, it's -8. Okay, -8. So right there, I have a -8 right here. And but with these information, we can go ahead and draw the graph. Okay, now, so for this part, I want to take this opportunity to go over the multiplicity of 3. Please try your very best to draw an acceptable look of the cubic function, which is like this. Okay, like when we have a triple root or the root with a multiplicity of 3, that means it's going to pass through the x-axis as if it is the x cubed graph, the little special turn right here. Okay, now, so I hope that you look at the inequality, you look at the left-hand side, you saw the polynomial, and you say, oh, hey, I have 2 options. I can expand it, or I can make a graph. You can try either, or you can try both, actually. But what I want to remind you is that before you actually pick up your pencil and start writing, can you see the destination? If you cannot see the destination, don't go forward with this strategy, because it will not get you anywhere. It's very unlikely that you will get to somewhere if you don't even know if it will lead you to the destination. So in this case, graphing will lead you to the destination. And the answer is really right in front of you if you are actually looking at the notation. And at the same time, as I said in class, please make sure that you know the meaning or definition of the word solution. When you say solve, when you see the word solve, it means that we need to find the solution. And the meaning of solution is to find the value or values that makes a statement true. Okay, it's the value or values that makes a statement true. And if it doesn't make the statement true, it won't be included. And that's it. So what statement are we looking at here? We are looking at this statement. We would like to find out the x value or x values that would put the polynomial above 0. We want to find the x values that would give the polynomial a positive value that's bigger than 0. And the graph, it's your best approach because the graph shows you vividly and explicitly which part of the graph it's greater than 0. And it is this part right here, not including the -1, and this part right here, not including the 2, because -1 and 2 would make the polynomial equal to 0, and we don't need the x value that would make it equal to 0. Okay, we don't need the x values that would make the polynomial equal to 0. We need the x value or x values that would make the polynomial above 0. So therefore, the solution for this particular problem is that we will go from -infinity to 1, union 2 to infinity. That's how we get the solution, or the solutions in this case. Okay, we have a bunch of x values here, and that's why we use interval notation, because we are not looking at one value, we are looking at a bunch of values. So just to recap, okay, now please do not force your memory to remember what to do. That usually won't end well. Please try to understand the notation. Understand the word that you're reading. And I'm saying this because I used to be a kid who did not understand the words. I did not understand the notations, and I just relied completely on my memory to do the math problem. So it's really like a hit or miss. It's not showing you what you understand. It's really showing how good your memory is, and that it's not what you want on a math test. Because, as I said in class, our memory usually sucks, especially with all these numbers and symbols. Our brain would get interfered very easily, and we tend to memorize the wrong thing. But if you know how to read the notations in front of you, if you know how to understand the word solve, which means to find the solutions, and solution is to find out the value or values that will make the statement true, the answer is really right in front of you. Okay, so again, you look at this polynomial right here. So if you attempted to expand it, then ask yourself, what is the good of expanding it? Do you see how after the expansion, would you get the solution? If you cannot see the destination, do not go with that option. Just do not. Hold yourself back. Think again. Because if you cannot think of the solution right now, if you cannot think of seeing the destination right now, it probably won't happen after a few seconds of working the whole thing out. So the strategy is really about knowing what you're looking at, knowing what you're reading, come up with a solid strategy that would lead you to the destination. And for this one, just make a graph. Just use your knowledge of graphing polynomial to make a graph, and the answer is right there in front of you. Okay, so I hope this video would be, you would find this video very beneficial for you, so that you would never ever miss this kind of question again, because you understand the meaning. And as a way to check your own understanding, see if you can verbally explain how we get to the graph, why we draw a graph. Focus on the why, not what to do, but the why. Why do we choose to make a graph instead of expanding? If you can verbalize it, you're good. Okay, and we say, oh, we make a graph, it's because of, well, it shows where of the which part of the polynomial it's above 0, very, very explicitly and vividly, and we have no concern, no fear of not getting it. Okay, so please make sure you verbalize it. All right.